This is a continuation of lesson 1.1 where we present a function. So we're going to continue looking at investigating even and odd functions and working with piecewise functions. So this is really a piecewise function. You're going to break it into sections into your own windows to see where, if you can determine the formula for each. And so this is just a linear, and so you want the y-intercept and the slope. So the y-intercept for this blue section is 0, so b equals 0, and your slope is 1. So you have the equation y equals x. And in this next section, if you extend it out, your y-intercept would have been 2, and your slope is equal to negative 1 because it's down 1 over a positive 1. So this is y equals negative x plus 2. And for this last section, your y-intercept is 0, and your slope is 0. So this is just y equals 0. And then you just have to tell me what the window sections are. So y equals, and instead of a y, we write as a function, so f of x equals. And it's equal to x when x is greater than or equal to 0 and less than or equal to 1, because that was our first window here. And then it is equal to negative x plus 2, and we don't want to double up the 1, so you could have had the equal to up here or down here, but when x is greater than 1 and less than or equal to that's 2. And then last but not least, the purple section, y is equal to 0 when x is greater than 2. That's it. Here's another one. This one is a semicircle. The equation of circle is x squared plus y squared equals r squared, and the radius of this is 1, 2. We want to solve for 0, or for y, sorry. So y squared is equal to 2 minus x squared. And then we take the square root, 2 minus x squared, and since we took it, we want a plus or minus. Okay, so that's the middle section, and then for this section, slopes 1, 2, 3, down 3 over 2. So we're going to go down 3 over 2, 1, 2, 3 over 2, and that would make our y-intercept negative 2. Yeah. So b is equal to negative 2, and our slope for this one is down 3 over 2. So that would be y equals negative 3 halves x minus 2. And for the side on the right, it has the same y-intercept, and your slope is positive 3 halves this time because it's going up. So y is equal to 3 halves x minus 2 again. So then we just need to write it in the windows. So I'm going to scoot down here. I can still see the windows up here, I think. So that's a negative 2 right there, and that's a positive 2. So f of x equals, and then we'll use the black one because it's the one farthest to the left, negative 3 halves x minus 2 when x is less than, we'll do just less than on this one, negative 2. And then the middle section is the blue, plus or minus the square root of 2 minus x squared when x is less than 2 but greater than or equal to negative 2. And then the purple, which is the farthest to the right, 3 halves x minus 2 when x is greater than positive 2. And that's your piecewise functions. Just split them into sections and go for it that way. All right, even and odd. So a function that is even, okay, if you plug in a negative x everywhere that you see an x and it comes out as your original function, then it's even. Okay, so right here, if I plug in a negative x here, and I square it, it comes back as an x squared, which was the original function. So it's even. You can also tell by looking at the graph because it will be symmetric with respect to the y-axis. The other kind of symmetry is an odd function. So if you put in a negative x, you're going to get the opposite of the whole function, and then it's an odd function. So right here, I put in a negative x. Everywhere I see an x, it comes out exactly the opposite of the original function. You can also tell by looking at the graph because it will be symmetric about the origin. What that means is that I can rotate it, and at some point before a 360-degree rotation, it will match up and look the same as the original. So here are 3 different functions. We're going to determine if they're even, odd, or neither. So I'm going to, for these, I'm going to do it algebraically. You can also look at the graph and tell. So if I plug in a negative x, everywhere I see an x, this will give me a negative x to the 5th minus x, which is exactly the opposite, so it is an odd function. Let's try the second one. 1 minus a negative x to the 4th, that gives me a 1 minus a negative to the 4th, that's still positive, so this is x to the 4th. It matches exactly, so this is even. And then looking at this third one, again, plug in a negative x. Oops, forgot the negative. This gives me a negative 2x, a negative squared still positive, so that's minus x squared. That's not exactly the opposite, and it's not exactly the same, so this is neither. So word number 1 is have. All right, increasing and decreasing. So you guys know about increasing and decreasing. So if the function increases, that meaning every x2, as we go up, it's going to be greater than the one before. So this one is increasing on the interval from a to b, and it's decreasing on the interval from b to c, and it increases again from c to d. I think these should be parentheses, not brackets. Because at the point right here, it's neither increasing nor decreasing. So what all this says is that if between x1 and x2, so 2 different x's, if x1 is less than x2 and f of x1, so y, is less than the other y, is going to be increasing. So this is f of x1, this is f of x2. And then the other way, if you have x1 here and x2 here, if f of x1, so the y, is greater than f of x2 right here, it's going to be decreasing. And so the key here is that it has to be true for every value inside the interval. That's all it's saying. Any number I picked in this interval from x1 to x2, it has to be satisfied that. All right, so where is it increasing? Where is it decreasing? You tell me the increasing in this video, and then followed by the decreasing. So keyword number 2, fun.